You are welcome to online lectures with From Eternity the Schoolboy. Today we are going to take a look at chemistry, and we have a question on the board. The question says, a metal X forms two bromides with the formula XBr subscript 2 and XBr subscript 3. What type of bonding exists between X and bromine in the bromides? Option A, ionic bonding. B, metallic bonding. C, dative bonding. D, covalent bonding. The question source is JAMB 2007 Chemistry. Question 3. Let's go back to the question. From the question, actually Br represents bromine, but with different subscripts. There's a reason for that. We'll go into that. Now, let's go back again. The question says metal. So X is actually a metal. Bromine, bromide, from bromine. Bromine is a non-metal. Bromine belongs to group 7. Group 7, under group 7 we have chlorine, fluorine, chlorine, bromine. So bromine, they are known as halogens. They are actually highly electronegative elements. And they are on their outermost shell, they have 7 valence electrons. So it's difficult for them to move the whole 7 valent electrons. So they now undergo either covalent bonding by sharing electrons, or electrovalent bonding or ionic bonding by accepting electrons. Either of these is aimed as achieving the octet electronic configuration to ensure that the outermost shell electron, the valence electron, is 8. That's why they undergo either of these. So from the question now, if bromine is actually combining with a metal, bromine will do what? Will accept electron from the what? Metal, because metal on their own, they donate electron, because on their outermost shell they have 1, 2, or 3 as the case may be, so they can easily donate electron. So this process, valence electron, so this process of either donating from one and accepting from the other by the other, this type of bonding is nothing but electrovalent bonding or ionic bonding. Now, on coming to why, to know the reason why we have XBr subscript 2 and XBr subscript 3. Let's go. Actually, in this transfer of valency, getting donating electron and accepting electron, actually there's this thing. We have something like this. Good. Before I go into this, I want to make a point. Please, this we have already established that this and this, what is in between this and this is ionic bonding. But we don't need to confuse this with what is formed from covalent bonding. These things are not molecules. Actually, this X and bromine, they exist. This X and bromide ion, this X ion and bromide ion, they exist as ions that are attracted This ionic bond is that attraction between these two ions, X ion and bromide ion. So we have something like this. Of course, we all know that halogens in ionic form, they have something like this. In ionic form, you have something like this, bromide ion in ionic form. While X, we have is a positive ion. Bromide ion is a negative ion. This is how they appear on their own. But this X is positive ion. Now, how do we now know whether X is, yeah, we know it's plus. Is it plus 1? Is it 1 plus? Is it 2 plus or 3 plus? How do we now know? We can only know by looking at what is called transfer of valency. For this thing to be formed, X has to transfer its valency to what? Bromine, while bromine transfer is own to what? X. So we actually have something like this. After the transfer, we have something like this. We have something like this. So this bearing the valence of this one, this bearing that of this one. That's why there's no 1 here. So if that is the case, that means in this case here now, X actually, it should be what? 2 plus. For it to transfer its own to bromine, and bromine transfer 1 here to form this. That means X is what? 2 plus here. And bromine is what? Bromine is what? Minus 1. Now, what does this also imply? This also implies that this require two bromide ion to be able to do what? To be able to completely form this ionic bonding between bromine and what? Bromide ion and what? An X ion. So 2 bromide ion are required here. So this requires 2 what? Bromide ion. Now let's go over to here. Using the same pattern here, X here is what? 3 what? Plus. While bromide is still this. So for this bromide ion to completely form this bond, let me put minus so I don't confuse us. To completely form the ionic bond with this, we require 3 moles of bromide ion. This will require 2 moles of bromide ion. So we require 3 moles of bromide ion. Each of them face 1 plus 1 of X. So we have something like this. So what it also implies is that X has 2 oxidation states. We have two valence states. We have plus 2 and plus 3. Even though they didn't mention the metal, but a metal that has this type of this thing, ion also exists as this. We have ion 2 and ion 3 what? Ion. We have ion 2 and ion 3 ion. Let us not go into exposing or talking about what X could be. But ion exists as ion 2 and ion 3 ions. So from this explanation, it's clear that what is between X and bromine is what? Ionic bonding or electrovalent bonding. So let's look at the option. Option A says ionic bonding. So I will tick this. Option B says metallic bonding. Metallic bonding doesn't require 2 different elements. It exists in only 1 element. mostly, which is a metal. So it just, metallic bonding is just the force of attraction that keeps the atoms of a metal together in a what? Lattice form. Simple. So it just exists between the atoms of a metal. So it has no business with another element, just atoms of a metal. So this one is not the answer, because this involves two different what? Elements, a metal and non-metal. But this one is within a metal, atoms of a metal. That's where this attraction exists. It's actually one of the other binding forces, apart from the major bonding types we have. We have this alongside with hydrogen bond and what have you. Now, I will not choose this. Now, C, dative bonding. In dative bonding, there is sharing of electron. Dative bonding is a type of covalent bonding. So we have two types of covalent bonding. We have ordinary covalent bonding or coordinate covalent bonding. So dative, you call it dative bonding, is also known as coordinate covalent bonding. Just as we have in basically that's sharing of electron, but what happens is now where is the electron to be shared coming from? In dative bonding, only one element or only one atom contributes the electrons to be shared. We call it this electron lone pair. Only one atom contributes the one to be shared. This type of bonding exists between hydrogen and the hydrogen and the water molecule in ozonium ion. Yes, even in between hydrogen and ammonia in ammonium ion. Basically hydrogen and nitrogen, because the nitrogen atom in ammonia has a lone pair, so it will bring it for hydrogen, so that hydrogen can reach the what? Duplet electronic what? Configuration. So dative bonding is not the same thing, is not what exists here. So I will not pick this. Then covalent bonding. Each time we mention covalent bonding, our mind goes to ordinary covalent bonding. Here, there's sharing of electron, but the two atoms involved equally donates the electrons to be what? Shared. So this is not what? The answer, because there's no sharing of electron here. So the answer to JAM 2007 chemistry question 33 is A, ionic bonding. Thank you very much for your attention. Please, if you have any question, feel free to chat me up on WhatsApp. My WhatsApp line is on the screen. Please subscribe to my YouTube channel. My YouTube channel name is From Eternity, the Schoolboy. Follow me on Facebook, like my page on Facebook. My Facebook name is From Eternity, the Schoolboy. Please like my videos, comment on them, share my videos. Someone out there may be in need of these lectures. On weekly basis, I organize academic competition I titled Academic Battle with From Eternity the Schoolboy. Every Saturday between 10 and 10:30 a.m. It features different subjects and courses every week. Registration is free of charge. It's purely online. You can write it from anywhere, any part of the world. So far you have access to internet, you can write the exam anywhere, any part of the world. And there are prizes to be won. You are not paying anything for registration, and there are prizes to be won. Please, if you are interested in this competition, chat me up on WhatsApp so I can send you the link for the registration. God bless you. See you next time.